Hello everybody, I'm coming live from my office. With the snow coming, I'm just being proactive here. I'm making a video for tomorrow because I don't think that I will be able to teach for an hour and have my two children not physically harm each other. So my plan is going to be to talk about the homework, have you watch this video, jump back on the end of the Zoom, and take questions. So I'll run through this, give the ideas, and then as we approach the end of the period, I'll jump back on and take whatever questions we have. All right, let's do it. So refreshing on the idea of reference angle. So the reference angle is the positive acute angle formed between the terminal ray and the closest x-axis. So if we're in quadrant 1, there's my reference angle, there's my angle. Angle equals reference angle. Quadrant 2 goes up there. There's my reference angle. 180 minus angle equals reference angle. Quadrant 3. Angle minus 180 equals reference angle. And last but not least, quadrant 4. 360 minus angle equals reference angle. And those are going to be, essential as we move forward. So if we look at these 4 examples, if you want, take a moment, hit pause, try them out, come back. All right, so 200 degrees, key thing there, quadrant 3. What's my rule? 200 minus 180. My reference angle is 20 degrees. 340, quadrant 4. 360 minus 340, 20 degrees. Now, one question I got the other day with the other class, is 20 a common answer? It's just a coincidence. Just a coincidence. All right, now, with radians, I'm going to keep stressing getting comfortable with radians. But a lot of people at this moment kind of probably despise it. So what I like to think about is, I make my unit circle in terms of radians. So here I got 0. This is pi, but know what? With our common denominator of 4, this is 4 pi over 4, making this 2 pi over 4, 6 pi over 4, and 8 pi over 4. So by doing that, I could figure out that our angle is in the second quadrant. So now our rule in the second quadrant is 180 minus the angle. So here, 180 is now 4 pi over 4 minus 3 pi over 4, which gives us pi over 4. But, shortcut method, denominator. What we learned the other day with the unit circle. If the denominator is 4, the reference angle is 45. For part D, I don't even need to do the work. I see denominator of 3. That means my reference angle is pi over 3. Every single time that will hold true. Now, just to do it like part D. So if I'm focused on divide by 3. Here's 3 pi over 3. Here's 1.5 pi over 3. Here's 4.5 pi over 3. Here's 6 pi over 3. Well, 10 pi over 3 goes outside of that. So that's too large. So if I subtract 360 from there, which in this case is 6 pi over 3, I have 4 pi over 3, which puts me there. Now the rule is, when you're in the third quadrant, angle minus 180 gives you the reference angle. So yeah, that works. But in the situation, hey, shortcut method. Right, shortcut method, I see divide by 3, the reference angle is divided by 3. Divide by 6, the reference angle is divided by 6. Right, so pi over 3, pi over 6. And if it wants it to be in degree measure, just convert back. Alright. Another type of problem. Again, we're working our way towards the overall situation. I feel like we've been taking like this meandering route to get there, but step by step by step to kind of understand what we're doing here. So if I'm looking at sine of 695, I subtract 360, and I have sine of 335. All right, so that puts me over there. Now the key thing is this, A, S, T, C. All right, so my reference angle, 360 minus 335, is 25 degrees. Since I'm in the fourth quadrant, cos is positive, negative sine of 25 is my answer. So sine of 695 is the exact same thing as negative sine 25. In the fourth quadrant, cos is positive, not sine. Alright, so if I'm looking here, right away, I know my reference angle. I see divide by 6, so my reference angle is pi over 6 for 30 degrees. 7 pi over 6. Alright, so this would be 6 pi over 6. This would, no, that'd be 3 pi over 6. Oops. Messing up things. 6 pi over 6. This would be 12 pi over 6. This would be 9 pi over 6. This would be 3 pi over 6. So that puts us here. A, S, T, C. So we're in the third quadrant. So in this situation, cos is negative. Right? Negative cos of pi over 6. Take a moment, pause, try out the next, how many examples we got? Next 4 examples and see how we're doing. Alright, ASTC, we are there. Alright, if we add 360 here, we're talking about cos of 330, which gives us a reference angle of 30 degrees. So our answer is cos 30, and it's positive because cos is positive in the fourth quadrant. Subtract 360, sine of 140. Reference angle would be 40 degrees. 140 is in the second quadrant. So it's positive, so it's just sine of 40 degrees. I do a bad job. I always forget the degree symbol. I don't want anyone to tell me it's 40 radians. No, it's degrees. Alright, negative 7 pi over 5. If I add 10 pi over 5, that puts me at cos of 3 pi over 5. All right. Based on my idea of my circles, A, S, T, C, this would be 5 pi over 5. This would be 2.5 pi over 5, so that puts me in the third quadrant. All right, now, there's no divide by 5 rule, right? So divide by 5 doesn't have, oh, divide by 5, the reference angle is pi over 5. No, not the case. Only works when we talk about divide by 6, 4, and 3. So in this quadrant here, 180 minus the angle, 5 pi over 5 minus 3 pi over 5 gives us 2 pi over 5. So our answer here, negative cos of 2 pi over 5. Why is it negative? Because in the second quadrant, cos is negative. Divide by 3. Reference angle, pi over 3. Alright, so what quadrant this is in? Is this in? Can't talk it sometimes. 3 pi over 3, 4.5 pi over 3, 6 pi over 3, ASTC, fourth quadrant. Negative sine of pi over 3. Alright, moving along. Now, I always think this goes back to geometry. There's nothing worse when I'm teaching geometry and people have no idea what mode they are in. What am I doing? What is my calculator telling me to do? Well, if you have degrees, you must be in degree mode. If you have radians, now a common thing is people always think radians, they want to see pi. Cos of 5, that's not cos of 5 degrees. There is no degree symbol. So if you have a cos of 5, You are in radian mode. And I'll always say, please ask me. If you're not sure, should I be in radian? Should I be in degree? Is that a radian? Is that a degree? Ask, I'll help. Alright, but if we're in the right mode, sine of 122 is 0.8480. Cos of 5, not cos of 5 degrees, cos of 5 radians is 0.2837. Yeah, I wrote the wrong number and I tried to fix it. And we were talking about before the unit circle. So we got 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. If we go in terms of pi over 2, pi, 3 pi over 2, 2 pi. You know what? How about we go in terms of radian decimal? Right, so if you do pi divided by 2, it's about 1.57 radians. Pi as we know it, 3.14 radians. Down here, 4.71 radians, and over here, 6.28 radians. All right, so key thing, understanding, this is the same, these are the same, those are the same, those are the same. They're all the exact same spot. All right, so if we're looking at 5, right, cos of 5, that puts us about here, right, because we're between 4.71 and 6.28. Cos of 5 has its terminal ray in that fourth quadrant right there. And it makes sense based on ASTC. ASTC. Cos is positive, so that does work. All right, we're still getting to the big part of this. What are we working towards? All right, here we have it. We want to answer these without a calculator. All right, so what's a central minus? I need my unit circle. I need my unit circle. All right, so I got 30, 45, 60. Here's my 1, 0, my 90 degrees, 0, 1. My 180 degrees, negative 1, 0. My 270 degrees, 0, negative 1. All right, 3, 2, 1 method. 3, 2, 1. 3, 2, 1. All over 2. 3s and 2s get rad. Perfect. I'm good to go. All right, so sine 30. I'm in quadrant 1. Again, always got to focus back on ASTC. My reference angle is 30 degrees. So if my reference angle is 30 degrees, I'm focused on rad 3 over 2, comma half. So, we got to remember, sine is y over r. But on the unit circle, it's just y. Cos is x over r. But on the unit circle, cos is just x. So if I'm in quadrant 1, I'm focused on just y. Sine of 130 equals 1/2. 210. 210 minus 180 gives me a reference angle of 30 degrees. I'm in quadrant 3. ASTC. Right? 30 degrees. Rad 3 over 2, comma half. Sine 210, third quadrant. In this case, I have sine of 210 is negative 1/2. Why? It's the y value. And then in the third quadrant, sine is negative. And this is what we've been working towards all along. All right, so take a moment. You got these 5 examples. Pause, try them out, come back, check your work. Let's see how we are doing. Okay. All right. I'm in quadrant 4. ASTC. I'm there. Divide by 4 tells me I'm focused on 45 degrees. And the point rad 2 over 2, comma, rad 2 over 2. All right, so cos 7 pi over 4 equals rad 2 over 2. It's positive because in that quadrant it is positive. While on the other hand, same idea, ASTC, I'm in quadrant 4. My reference angle is 45 degrees. My point's rad 2 over 2, comma, rad 2 over 2. But in this quadrant here, right, in this quadrant here, sine is negative. So sine of 7 pi over 4 gives us negative rad 2 over 2. Now if it helps, also thinking about the work here, quadrant 4, understanding this is negative, this is negative. So you could label the point with a positive and negative so you don't have to necessarily always focus on it. So if I jump over here, divide by 3, that tells me my reference angle is 60 degrees, which has the point 1/2, comma, rad 3 over 2. ASTC, I'm over here, which in this situation makes x negative, so cos of 2 pi over 3 equals negative 1/2. Divide by 6. All right, my reference angle is 30 degrees, so my point is 1/2, comma, rad 3 over 2. All right, what quadrant am I in? ASTC, 5 pi over 6 puts me in the second quadrant, so x is negative. Sine 5 pi over 6 is just the y value. Oh, I messed up. Oops, I realized that doesn't make sense. Point was backwards. Rad 3 over 2, 1/2, negative rad 3 over 2. Well, there's a correct point. So my answer is positive 1/2. And I have the unit circle in front of me. Unit circle is essential to succeeding in this class. All right, divide by 3, 60 degrees. So again, I have that point 1/2, rad 3 over 2. All right, ASTC. What quadrant, man? Fourth quadrant. Y is negative. All right, so sine of negative pi over 3 equals negative rad 3 over 2. All right, there we have it. If we have questions, let's reach out and make sure things are going okay.